the only question I had on the preparation assignment was, oh, what number was it? I hate how they keep using the management admissions test for the MBA program. I think they're trying to scare us. This is a subconscious weaning process. Oh, crap, now what number was it? Oh, on number 10, it says, how does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95% confidence interval of a sample size 100? Now, would we just compute those the same way as, like, the 100 is the same?
Just saying, yes, so you compute the 100 as the same. So, I mean, you just exchange the 50. Instead of being the square root of 50, it's going to be the square root of 100.
Okay.
And then you just compare which numbers are bigger, which ones are, smaller, closer together.
Okay, by putting them in the applet and seeing the... Do you put that number into the applet at all, or that's just the number? Okay.
That's just the number.
Okay. Cool.
Okay. You'll get two numbers off that, because you'll need to do one that's plus the number and another one that's minus that.
Yeah, that same. Yeah, that 2 deviations from the mean thing. 2 deviations plus, 2 deviations minus.
They just left on a couple's mission.
Okay. Okay. Cool. Other than that, Taylor, did you have anything? Do you want to go ahead and start the quiz?
I'm good if we want to go ahead and start.
Okay.
First two answers should be easy enough.
She had a bunch of clothes that she wants to get rid of, so she wanted me to look through them.
Okay, we'll open the applet.
What's the equation for this? I don't have any of my notes. They're all in Word documents.
Let's see.
Okay, but
The margin of error formula that I have is M is equal to 2 times the standard deviation over the square root of N.
Jazz and I are going over. Jazz and I went over last night, and we were playing a game with them. So Jazz and Sarah are going to go back over and Taylor was going to join us. You guys will be able to do whatever you want, because either Taylor can come back and pick us up, or
so where would the margin of percent fit into that? Would that be the 2?
Your audio was breaking up. I didn't understand your question.
Oh, so where does the margin of error or the confidence interval fit into that?
Let's see. Okay, this one says this. No set. Okay, that one says approximately 95%, so I don't know if that one would work.
So one of the equations that it has here, so for the margin of error, like you said, it's 2 times the standard deviation divided by the square root of the number. So in this one, divided by 5, since the square root of 25 is 5, is 10, times 2 is 20. The margin, so that means that the margin of error here would be 20. And then it starts going on and saying, using this definition for M, our confidence interval can be written as the point estimate minus the margin of error, or the point estimate plus the margin of error.
So is asking for us to find the margin of error with a 90% confidence interval.
So do we,
Where is the confidence interval going to fit into the equation of m equals 2 times the standard deviation divided by the square root of n? Or does it just not fit in at all?
sorry, I'm looking. Now it keeps referencing the 68, 95, 99 rule, but how does that apply? But they're not asking for 95, they're only saying 90. But in the homework, let's see. Okay. So it says, what are the assumptions for creating? Okay, oh, let's see. Where's my... Ah. There. That's the thing I wanted. Okay, so we need to figure out what the point estimate is in order to, correct? Is anybody there?
Yeah, I'm
Okay.
sorry. I'm in my own thought process as well.
No, it's okay.
Because if you do it by what you guys said, you get the answer of 20.
Mm-hmm. Yep.
But like I said, I don't have all my equations,
No,
unfortunately.
you're okay. Well, I'm looking at the notes here, and once we figure out what that is, that 20, then it's saying if we collect a random sample of a population and the X with the line over it is normally distributed, then about 95% of the time the sample mean will be less than those 2 deviations. So I don't know if that's what it wants us to compute at this point, because this says 95, but the problem says 90.
Let me see my phone.
Okay, guys, give me just half a second. I'm going to leave for a second. I'm going to join on my wife's laptop, which will be easier to use.
Okay.
So I'll be right back.
So I'm seeing a z-score of 0.126. The area.
I'm calling you.
Hello. Hey, hon. Oh, honey.
That's easier.
Which part?
So we're on the side, same row as my car, just farther down.
Side of the girls' building. So I'm looking at another equation that's farther down. It talks about what about confidence levels.
Mm-hmm.
So it's talking about, suppose we want to create a 90% confidence interval. What value would we put in the blanks in the confidence interval below? Another way to
Okay, I'm back.
it says another way to state this question is to ask between what two z-scores will 90% of the data in a standard normal distribution fall? So we need to find the values of negative z and z such that the area between them is equal to 90. So that's when we use the normal probability outlet. So we highlight the two, or we highlight the section in the middle, which gives us, when we type in 0.9, because that's the confidence interval that we want, then that means that we have a z-score of negative 1.645 and positive 1.645. So then, in the equation that's a little bit farther down, what we would do is we would do, let's see, the number minus 1.645 times the standard deviation over the number, or over the square root of the number, and then the point plus that z-score times standard deviation over the number.
Okay, so that would be 20, right? We end up with 20, so we'll just times 20 by the 1.645.
It would actually be less, because 50 divided by the square root of 20, which is 5, that puts us at 10, so it would be 10 times 1.645, which gives us 16.
Oh yeah, we don't times it, sorry. Yep.
16.45, but then according to this, it would be a number plus that and a number minus that.
So do we get 16.45 as the answer to the first one?
I think so.
Which is just the same as putting 1.645 times 50 over the square root of 25, right?
Yeah.
Okay. So which of the following statements is true for number 4, right? That's what we're on?
Yeah.
Okay, just double checking since I left there for half a
So
second.
so the margin of error is 16.45. That's the answer.
I believe so. Yes.
Okay.
Which of the following statements is true? Isn't it the second one? I remember seeing that in there in the brief overview I had of the book.
Yep. It's if x is unknown, how do we know? Da, 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 da.
So now for this next one, what we would do is we would use the normal probability outlet and do 0.95 for that middle area, which gives us a z-score of negative 1.960 and 1.960. So we kind of do the same thing. We do 1.960 multiplied by, and then in parentheses, standard deviation over square root of the number, so 113 divided by, and then the number size is 64, so the square root of 64 is 8. So 113 divided by the square root of 64 is 14.125, and when multiplied by 1.96 gives us 27.685. So now, I may have done all of that. No, let's see, what is the point estimate for the true GMAT score? Wouldn't that be 526? since according to 4, x is a point estimator of 2. Hello.
Okay. Sorry, you lost me back at the square
Yeah,
root of
That's not, well, it's not something we had to do yet. For this next one, it says, what is the point estimate for the true GMAT score? And wouldn't that just be what x equals? Because in number 4,
Mm-hmm.
you're going to say number 2, x is a point estimator of u. And so,
Yeah,
would
so it would be
just-
526.
okay. So now for number 6, it wants, what is the margin of error for the 95% confidence interval? I got 27.65. And the way that I got that,
So we're computing the margin.
yeah, and the way that I got that, I did the same equation that we did before. So I did, I went onto the normal probability applet and found the area, 0.95 area in the middle section, which gives me negative 1.960 and positive 1.960. So then I came back here and I did, okay, well, the other part of it is standard deviation over square root of n, so 113 divided by the square root of 64, which is 8, gives me 14.125. And then I multiplied that by the 1.960, I believe it is, 1.960, which is what gave me the 27.685.
Wait, hold on. Go back to right before you got, because I got,
Okay.
so we did the 113 divided by 8, or divided
Yes.
by, yeah, 8 is 14.125.
14.125. So now on the normal probability applet, in the area at the top, if we punch in 0.95, because we want a 95%
Mhm.
confidence interval, then
Yeah.
we get, then our z-scores are negative 1.960 and positive 1.960.
Yeah.
So what I did was then I punched that in because, like the equation before, it's z times standard deviation over square root of n. So we already have the standard deviation over the square root of n, so now we just multiply it by z, which is 1.960. And I got 27.685.
27.685.
Mhm.
Hold up a second, because I'm just looking in the notes now that I have my notes here. If you look, wouldn't that be the same type of thing?
You
Wouldn't it
cut
be that
out
same
the,
equation? Oh, sorry. So if you're looking at the preparation assignment number 9, wouldn't we use that same equation? The 541, as you have there, it's 541 plus 1.96. Wouldn't you use that same type of equation?
you said for number 9.
Yeah. I mean, unless I'm totally
Yeah.
wrong.
I don't think we've gotten that far yet, right? So you find what that number is, and then you subtract it from the mean, and then you add it to the mean.
That would make sense. So we would do 5.6 minus 27.685. Well, no, because it's saying what is the
No.
margin of error for the 95% confidence interval. So just like we did in number 3,
Oh,
where we didn't have it, we
okay.
had 90% margin of error. But then I think for the next one, for number 7 is what you're talking about. So what's the lower limit of this confidence interval? So we would do, that's when we do the 426 minus
Oh, okay.
27.685, and that gives us 498.315. I believe. And then the other one would just be adding it, which would be 553.685.
Okay, hold on.
So you got 228.25 for number 6, right? Or
228.
28.25, sorry.
I got 27.685.
27.685.
Yeah, 113 divided by 8 is that the square root of 64. And you get 14.125, and you multiply that by that z-score that we got, 1.960, and that's how I
So
got
is it 113 divided by 8 or 113 multiplied by 8?
divided by 8.
Divided by 8.
Because just like we did in number 3, where we did the, what is it? 1.645 times the 50 over 5, so 10 times
Oh yeah.
1.645 gives us 1645. So for this one, it would be the same thing of 113 over 8 times 1.960.
Okay. Okay. Sorry.
Now, if I end up getting, like, I'm going to be the one to submit this, because if I've been giving a lot of stuff, and so if they're all wrong, then I can just, put on my dunce cap and start thinking harder. So,
and then we use the equation for number 7, like I was talking about.
yes, for number 7 and number 8. I'm going to go use the restroom real quick, so I'll be right back while you guys do those ones.
Okay. So, Sandy,
Yes.
for number 7, I got 498.315. Is that what you got?
Yes.
Okay. I'm just double checking now that I'm getting all caught up.
No, you're good. I had to do it a couple times just to make sure I was getting all the right numbers. And then for number 8, I got 553.685.
Yep, 553.685.
Mm-hmm.
And then do we want to wait for him for question 9?
Yeah. It gets smaller.
Yeah.
Kind of like the opposite, but we'll wait for him.
Yeah, because the margin of error gets smaller as the sample size grows larger.
Mm-hmm.
So. Which makes sense.
Mm-hmm. Number 10 is going to be increased. It says here, increasing the confidence level will lead to larger values of Z. If Z is increased, then the margin of error would increase. This would lead to a wider confidence interval.
Yeah.
Which almost seems like counterintuitive to me, because it seems like the closer to 99 you get, the more confident you are. So the space or the deviations that you would have would be smaller, not bigger. But
Yeah. If you divide it out, then it makes more sense.
I guess they think the higher number you have, the more likely you are to screw it up. You're a little overconfident.
Yep, probably.
Okay. Oh my goodness, now we're solving for n. Eee. Sorry.
Oh, you're fine.
Okay, sample size calculations.
Yes.
Okay, so it's going to be n is equal to, and then in great big parentheses is z with a little star. And it's saying once the confidence level selected, Z is automatically determined in practice. The most common level of confidence is 95. It says here, yep, that we want 95. So our Z is going to be 1.96. That's what the little starry things. Z times the standard deviation divided by M. That's the margin of error. The second parentheses, and then you times that by 2. Or you square it, sorry.
So it's, sorry, what?
That's okay.
Minus.
Yep, you got n is equal to, and then a great big parenthesis. And within the parenthesis is the formula z times the square, or times the standard deviation. So z times O divided by m, as in Mary, parenthesis, and then a little 2 at the top. So you take that answer and square it.
Okay.
So that's the formula that we're working with.
Okay.
So our z is going to be 1.96 times 400 divided by, let's see, a margin of error of 50 hours.
Yep. And all that squared, right?
Mm-hmm.
Okay.
Okay, I got a number, but I don't know if that's. Let me open Excel here. Find that when I do it on the calculator versus in Excel, sometimes I get the same number and sometimes I don't.
I got 245.8624 in Excel.
Yay! Okay, that's what I got.
And we're supposed to round to the nearest whole number.
Okay,
So 246. Is Taylor back yet? Nope.
the mean salary of actuaries is 100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different than the population mean.
I came back and Sandy was talking. Which one are you guys
Sorry.
on right now? No, you're good.
We're up to 12, but we can go back.
Oh, geez. Okay. Well, let's see. Because we got 7 and 8. It was just the 526 minus 27.685 and add it.
Yeah. And then
what
for
would happen?
9,
For 9, that would be no change.
decrease.
It would decrease the width of the confidence interval.
Yeah, so if you have a larger sample size, then your confidence interval is the width of it's gonna decrease because you're more sure of it.
Okay. And then for number 10, it would be an increasing confidence interval.
Yeah.
Okay. Okay. And the
And then number 11, we'll let you see if we got the same.
Yeah, let me-
See if we got the same numbers.
yeah. So basically, they give you the standard deviation, they give you the confidence interval, and the margin of error, but we don't have x, so we just have to switch that and find x. So the sample size that they're looking for, number 11, would be that X with the line over it, right?
I think they're looking for n. What did you get as your answer, though?
I haven't done much calculating
Oh.
because they're they're wanting how
I
many.
think they're looking. Yeah, they're looking for the sample size, so I believe that's n. Which we found
Yeah.
the equation
hang
for
on.
that.
I'm gonna see if I can. I just want to see if I can do this one. Like if I know what I'm doing or if I'm just.
Yeah, no, that's fine.
So the equation that I got, I basically took the margin of error equals z-score times standard deviation over the square root of n, and I just did some like some changing in order to move n over to the other side to get it by itself. So I got for the equation n equals parentheses z-score times standard deviation over margin of error squared.
Yes.
So that means it would be, if that is 0.95, 1.960, standard deviation of 400, margin of error 50, 1.960 times 400, and 4 divided by 50 15.68 and then squared. So 245.86, but that would be rounded up to 246.
Yeah, 246. Yay,
Cool.
we're all on the same page. That's awesome.
Yay. Okay, cool. My iPad, I found it again, and so I've just been charting it, and I can use the notes in order to actually like draw on it and write out my thoughts instead of having to find pencil and paper every time. I legit, like yesterday for my economics class, there was some math I had to do, and the only thing that was close to me when I was like on a roll was those little like magnetic, it's this pen connected to a little screen, and when you draw on it, it makes black marks, and then you can swipe this thing up or down or left or
You're
right.
talking about an Etch-a-Sketch?
An Etch-a-Sketch. I had a tiny little Etch-a-Sketch. Hang on, I'm gonna activate my camera right now to show you what it was that I did some math on yesterday.
Oh, this I gotta see.
Yeah. So today I'm using my iPad. Nice. And I even have like a little stylus, which makes it easier. Well, yesterday I was using this.
That is
And
awesome.
I was using it to etch on my ideas as I was going. And then when I got done, I was like, okay. And I would remember the last number that I needed, and I'd erase it. And then I'd continue going with the calculations I was doing for GDP and everything. It was great.
I think you should get bonus points for that.
I
know.
think so too.
I'm gonna let
You
my
should get a
teacher
boogie
know.
board. Have you seen the boogie boards that they have?
No.
They're pretty awesome. My sister got one for Christmas. So it's basically the same idea, but instead of having to swipe that little arm, and you use a little pen to draw on it and everything, but
Okay.
instead of swiping it, you just hit a button and it erases everything. They're
That
pretty
sounds so
awesome. I've seen like 8 kids in our ward like using them. It's ridiculous. Yeah,
Like,
they're
and-
really popular.
College students get that much money to buy stuff like that.
Well,
that's
when I say kids in my ward, I'm in a family ward because I'm married, so they're like
Yeah.
8 to 10 years old.
Ah, gotcha.
Yeah,
Holy cow.
Yeah.
And for me, for like this iPad, I bought it last year. I got a birthday discount, and so I got 30% off on it for my birthday. So that's how I'm able to afford my fun toys.
I don't afford fun toys. That's why my laptop is broken.
Amen. Amen. I know my daughter, she was about 1.5 years or so, she got a hold of my laptop. Well, it was my husband's at the time, but it's since been passed down to me and he's back to his desktop. But she pulled a bunch of the letters off, the numbers and things. And I'm still missing like a tab key. I think a couple letters are still gone because we just couldn't get them back on, but she'd pull them off and chew them.
Oh gosh.
So it's like, yeah, we're, let someone break in. They're not going to steal a laptop missing half the keys.
Yeah. I should just get a desktop. It's so much easier sometimes.
Yeah, that's
Okay.
probably what I'm gonna end up doing. Have like this rinky-dink little laptop for school, but have a desktop that's fully equipped for anything.
Yep.
Okay. So the equation is margin of error equals z times standard deviation over square root of n. So did you guys already do 12 and 13?
Not quite.
No.
Okay. Let's see. So m equals 1.96 times 36730 divided by the square root of 36. 6730 divided by 36 square root, which is 6, I believe.
Wait, on this,
Finding it very hard to find
I
the
can't talk.
motivation.
on this,
What's this?
where do we insert the 0.05?
I don't know.
Because I did it once in a different way, and I'm looking at what I did now, and that's not looking right at all. So,
Because what it's asking for 12 and 13 is
Mhm.
just what's the lower limit and what's the upper limit. That's basically
Yeah.
what we did for the other ones. I don't think it has any significance for these next two questions. It might just be there to throw us off.
Yeah.
okay.
I'm still confused by the whole equations thing. So which equation is which for this one? That's
So
the part
I'm-
that confuses me with this whole lesson.
So the one that I'm doing is I'm finding the margin of error right now. Because what it's asking for is what is the lower limit of the confidence of the 95% confidence interval. So when it asks us the confidence interval, it's basically saying when we're looking at the normal probability output and we type in 0.95 in the area, there's the bottom line and then there's the top line. So it wants to know what is that number at the bottom line and what is that number at the top line, or what is the lowest that our confidence would be and what is the highest that our confidence would be, something like that. So,
Okay.
so for this, what we would do is we would find the margin of error, which the margin of error for this is the same as what we've done in a lot of other ones. It would be m equals z times the z-score, which is 1.96 for a 95% confidence interval, times the standard deviation over the square root of n. So 1.96 times 36,730 over square root of 36, which is 6, which gives us basically a margin of error of 11,998.46.
I missed the last half of what you said.
Yeah,
I can't
Yeah.
hear you with the noise in the background.
He's got to yell at his roommates real quick.
Sorry.
Okay. Okay, so for that last half, what was the last thing that you heard?
Oh,
So we've got 36,730 divided by 6, which is the square root of 36, and then we times that by 2.
You multiply it by 1.96 because that's what the z-score is.
Gotcha.
So that gives us the 11,998.467 that we can now round it up to because we've finished finding what the margin of error is. And so from there, the lower limit of it, we would basically just take 111,000 from that sample size, and we would subtract this number, and we would also add this number for the lower level and for the upper level. So
Okay, so we're going to take the 111,000 and minus 11,998 and add 11,998.
Yep.
Correct.
So
Okay.
basic, and I don't know if it wants us to do 1198.467 with the whole rounding and everything. If it does, then our answer would be for the lower. Well, I mean, and if we're not rounding, I mean, I guess it doesn't really get.
Yeah, it says just round to the nearest whole number.
Yeah, so that's what I'm wondering for the 11,000. So basically, we would have 11,998 puts us at 99,002 for the lower limit, and then
99,002.
99,000 or 99002.
99002.
Yes.
Okay, so come here and run through how you got that again. Sorry.
You guys, so do you want the whole thing or?
Yeah, like just give what numbers did you punch in for what?
Okay, so I did 1.96 times 36,730 over square root of 36.
And that gave you 11,998.467.
Yes.
Right.
And so and Sandy said to round to the nearest whole number, so I rounded that, so just 11,998. So we take we're wanting to find the lower limit of this 95% confidence interval for the women's salaries that are in the sample size, an average of 111,000. So we would do 111,000 minus 11,998. Wait.
Okay.
That gives us 99,002. And then we would do the same thing, but adding it. So we would do 111,000 plus 11,998, which gives us 122,998.
Okay.
And also for question 14, it's all of the above. I'm going to go ahead and
Now,
submit
on
my.
Sorry.
Go ahead.
So go ahead, Sandy.
No,
sorry.
you go ahead.
I was just asking. So for question 13, it should be 122,998.
Yes.
Right.
Mm-hmm.
Sorry, my question was related to that. Do we do the 0.00 or do we just put the whole number and leave it?
I'm just going to put the whole number and leave it.
Okay.
Yeah.
I'm going to go ahead and submit mine. And let's see what we do, guys. Fingers crossed.
Yeah.
We got them all right.
14 is all of the above. Yep.
Yeah.
I remember that part
So
briefly.
I got number 1 and 2 right. 3, 4, 5,
So.
6, 7, 8. You guys did it. We got 100%.
Awesome.
Wow.
Yeah, I'm a little surprised, but I'm
That's
actually really happy
impressive.
with this. Yeah. Well done. First try.
Perfect.
Okay,
Oh,
so
man.
let me.
Not gonna lie, I was slightly worried.
Yeah, I know. When we first started out, I was worried as well. Before we end, does anybody have any questions about how we got to an answer on any of the problems, or which formula we used, or anything like that?
I think I do on 12 and 13 just a little bit. I mean, I understand like the concept of what we were getting at, and once we kind of got that number, I get where we, add and subtract.
Mhm.
But I'm looking back at the notes, and the formula that it gave us was the 2m is equal to 2 times the standard deviation over the square root of n. And did I miss that? Because I know we did the standard deviation over square root of n, but then we timesed it by 1.96, not by 2.
Yeah. So what I looked at when because what it's for that one, let's see. The confidence interval is actually a point of estimate at plus or minus the margin of error.
Mm-hmm.
So we did put the margin of error, and using that we can find it. So I see what I did was I just a little bit further down from that whole putting it all together and everything.
Mm-hmm.
What I did was I following it down just a little bit. It says the actual formula for a 95% confidence interval for you when the standard deviation is known
Mm-hmm. I
is,
see that.
and then it gives us that where it's sample size minus the z-score that's multiplied by the standard deviation over the square root of n. And so that's why I use that number.
Okay, the 196 instead of the thing.
Yeah, because I
Okay.
think because the other one is when it's unknown.
Okay, but we did know.
Oh,
Okay, I gotcha.
that makes sense.
Yeah, and so
Okay.
I think that's what the big difference between the two of them is. So that's why I use that equation instead of, because the thing that I just looked at was, okay, it wants us to find the confidence interval. Well, when it's talking about confidence interval and everything, we already know we'll plug it into the normal probability output to see, that area and everything. But then after that, the confidence interval is basically the margin of error plus, well, the sample number plus or minus the margin of error. And so I just went through and that's why I found the margin of error for it by using that equation and everything. It gave us everything that we needed to know, and so I just started putting in numbers.
Cool.
Okay.
Awesome. Cool. Thank you. Tell your roommate sorry I got him in trouble.
Very good. Is there any other questions that anybody had about any of these?
Nope. No, I'm good.
Yeah, I
Alrighty.
think I'm
Hopefully,
good. I do
you're
have
good.
one question, not about the quiz though.
Yeah. What's up?
This is the first time I'm posting this, so I hit stop broadcast, and then what do I do?
So you stop the broadcast, and then you'll want to go into the discussion board.
Okay.
So if you go back into
Like the
Math
group
221A
collaboration.
class,
Mm-hmm.
well, if you click in, yeah, right, that's exactly what it is. You just click discussions, and you can scroll down, and you can find, okay, we're in lesson 11, which is the most open one, and so you do that. You'll click start a new thread, and I guess what we're supposed to do is actually I guess we're supposed to post the link to the Google Hangout so that they can join, but whatever. I would just post the YouTube link, and then you also want to
And that's
post
just up here at the top of the screen, or how do I get the YouTube link?
the YouTube link. So the one at the top of our screen is the Google Hangouts.
Okay.
The YouTube tab open, right?
Yes.
So if you click the YouTube tab, then there should be a it should be on a screen that shows what it is that you're broadcasting. If you click that, it'll take you to what we broadcasted, and then you would copy the URL that's above that, and and that's what you would post.
Yeah. Yeah, so it should have a place where it shows all the recorded videos that you've recorded so far.
Okay.
If that
Another
makes
way to-
sense. So
let's see.
I'm just looking at it right now.
Yeah, another way is since we stopped the broadcast, if you clicked on the little circle that had your name, you hit Creator Studio, it brings you up to the dashboard. And on the dashboard, it shows all of the videos that you've got posted. And
Yep.
so you can go in there and you can just click on that first video that should be there for you, and then copy the link above.
Yeah. It's also underneath Video Manager under Videos.
Okay.
And that just shows all the videos you've had that you've recorded personally. So, yeah.
Okay. Cool. Well, I will give it a whirl.
Alrighty.
Okay.
Also in the comments and everything, put our names.
Everybody who was there.
Yeah, everybody who is there.